So hey guys, welcome back to Spider-Man's Lab. This is your host Spider-Man 6160, and today we are going to study mesh analysis. This is our question. We want to find the total current flowing through the entire circuit. So this is a very complicated circuit. Let's break it down into a simpler one. As we can see, this right here is a delta configuration. We can convert it into a star. Sorry, this is a star configuration. We can convert it into a delta. Which would be something like this, 100 volt. Please never forget to write the units while writing the values in the circuit, because when your circuit gets complicated, you get confused that this right here is a if you would have written it over here, then you would get confused that this is voltage or this is resistance value. So always write the unit. So this is 5 ohms, 15 ohms. So above what we have is 5. Sorry. So as we can see here, for delta configuration, we always have in the numerator is the combination of two of these, summation of all. So it is 5 times 10 plus 10 times 10 plus 10 times 5, which is 200. So let me erase that. That is always the numerator. So I'm doing it directly. Please do it with steps in your exams. So this right here is A, B, C. Now, as what we've studied in star to delta conversion, if we want A, then we must look at the opposite one. So that is 200 divided by 10. A equals, which is 20 ohms. And since B shares the same resistance, then that is also equal to B. And for C, 200 divided by 5, that will be 40. So we get here 40 ohms, 20 ohms, 20 ohms. So we can get rid of this. And we can simplify it in terms of so this one's right here, 6 ohms, 8 ohms, 20 ohms. This is parallel of 5 and 20, which is 20 by 5, which is 4 ohms, and this one is 40. This would be 10.90909. 10 0.90909 ohms. So what is a mesh exactly? Mesh is the smallest part of a circuit which does not contain a loop. Mesh is a closed loop in a circuit which does not contain any further smaller loops. So what can be our meshes right here? This is our mesh, and let's say I1 current is flowing through here. I1. This is our mesh, and let's say I2 is flowing here, and this is our mesh, and let's say I3 current is flowing here. So we apply Kirchhoff's voltage law in each of these meshes. So let's get rid of this middle part. L mesh 1. So here we can see there is a voltage source. So 100 equals. Now what we have to do is we go at this resistor which is shared by mesh 2 and mesh 1. So we simply write 8 times. Now this current is in this direction and this current is in this direction. So if it would have been on this side of the equal to, then it would have been minus I1 plus I2, but here it's on the opposite side, so it would be I1 minus I2. Next we move on to this one, which would be 10.90909, and now same, it is in the I3 is in this direction, it's going from here to here, and I1 is going from here to here. So it's again I1 minus I3. So 100 equals 18.90909 I1 minus 8 I2 minus 10.90909 I3. That would be our equation 1. Now same thing, applying KVL at mesh 2. So now we look at this one. So let's start from here. We are going from positive to negative, which means there is a potential drop. So we are going to write a minus sign, minus 6 times I2. Now we go to 20 ohms, which is shared by both the meshes, and again here the current as per I2 is we are going from positive to negative, but as per I3 we are going to negative, but as per I3, which is going upwards, we are going to from negative to positive, which will be an addition in potential. So what we do here is plus 20 I3 minus I2. Now again we go in at 8 ohms, which is shared by mesh 1 and mesh 2. So, and since they are in opposite directions, we go 8 I1 minus I2. Now, since it's Kirchhoff's voltage law, therefore it would be always equal to 0. Now, I don't like keeping the mesh which we are looking at in negative, so I just multiplied it with 1 on both sides. So that would be 6I2 plus 20I2 plus 8I2 minus 8I1 minus 20I3. That would give me 6 plus 20, that is 34I2 minus 8I1 minus 20I3 equal to 0. That would be our equation 2. We look at the mesh 3, KVL at M3. Sorry about that. So now I'm skipping these steps and directly writing the equation, calculating it all mentally. 4 plus 10.99 plus 20, that would give again 34.9, 34.90909. I3 minus 10.90909 I1 minus 20 I2, which would be 0. So let's put that into our calculator. Let's write the equations right here, so that would be easier for us. Not here, here. We want the answer right here. So 18.90909 I1 minus 8 I2 minus 10.90909 I3 equals 100. Then 34 point, sorry, minus 8 I1 plus 34 I2 minus 23 equals 0. That would be our equation 3. And 34 minus 10.90909 I1 plus minus 20 I2 plus 34.9099 I3 equals 0. That would be our equation 3. Let's put that in the calculator. 10.90909 x plus minus 8 minus 10.90909 equals 100, and it's minus 8, then 34, then minus 20, 20, it is minus 10.0909 minus 20, 34.90909 34.909 minus 20 minus 10.909 0 minus 20 34 minus 8 100 minus 10.90909 minus 8. Yes. So that is what I1 we get 15.40433 ampere. Now we had assumed it clockwise, so it is clockwise. I2 is equal to 9.73804 ampere, which is again clockwise, and I3 is equal to 10.93924 ampere, and that was again clockwise. So now we've got currents flowing through this, and this, but we needed the current flowing through entire circuit. So as we can see, the current flowing through entire circuit is nothing but I1. So that is equivalent to I. And the book also says 15.41 ampere in clockwise direction. So that is how we solved mesh analysis. This question using mesh analysis. Now there's one more type of question in mesh analysis, which is a bit tricky. Students find it tricky. That is called super mesh. Now let's take a look at that. Question we have right here is so these type of questions are called super mesh when we know a certain amount of current, that is 2 ampere. when we know a certain amount of current is shared between two meshes. So as we can see here, this is mesh 1 and I1 current flows through here. Also we need to find current through, and then we know a current flows from here in the mesh 2, let's name it I2, and there is current, and since it's in this direction I am taking the I3 current anti-clockwise. I3. So here we know that this current is being shared in these two meshes. Now if we go with our regular approach on normal mesh analysis, then we cannot solve this question because there's a shared current. Now how do we get to that? Now first let's go at mesh 1, because that is just a normal mesh. Let's do that. Applying KVL at M1. So now I'm just doing that all mentally. That would be our equation 1. Now there's an equation, as we can see, as per Kirchhoff's current law, current goes from here to here and here to here, and we know that this has only one way to go out, so it is 2 ampere. So I2 is coming in, I3 is coming in, and it is going out together as 2 ampere. So that with that being said, we can write a current equation that would be I2 plus I3 equals 2 ampere. Now many people also like to write it as 0 I1. It is up to your preference, and this can be our equation 2. Now with our current equation in the play, we can remove this branch. So that would make our circuit like this. So this one was our I1. Now with that diagram, we cannot just add these two and these two as they appear in series, but actually there's a branch connection in between, which we have removed it virtually. To solve this mesh, we call it super mesh S, and assume a current in clockwise direction. So when we solve this mesh, we have to see that what current is being shared in 10 ohms resistance in the original circuit. That would be, if we are looking in this perspective, that would be I2 minus I1, and in 2 ohms that would be only I2. In 1 ohms that would be only I3, and in 5 ohms that would be I3 minus I1. So let's take a look at super mesh. So 10 I2 minus I2 is going up, I1 is going down, so I2 minus I1 plus 2 I2 plus 1 I3, or simply I3 plus, now 5 is being shared with I3 and I1, so 5 into I3 minus I1, and that would give us I1 minus 15 I1 plus 12 I2 and plus I3, which would be equal to 0, and this is our equation 3. Let's write down the equation here. 15 I1 minus 10 I2 minus 5 I3 gives us 50. 0 I1 plus I2 plus I3 gives us 2 ampere, minus 15 I1 plus 12 I2 plus yes 6 I3 equals 0. So let's put that in the calculator again. 15 minus 10 minus 5, 50, 0, 1, 2, minus 15, 12, 6, 0, and that sets I1 is equal to 20 amps, and since it is going clockwise, which we had assumed earlier, it is clockwise. I2 is equal to 46 amps. We had assumed it also clockwise, and that would give us, and then finally I3, which is 48, sorry, my bad. This we are getting minus 46 amps, which we had assumed earlier anti-clockwise. So if you look at this I1 plus I2 plus I3, that would be equal to 48 minus 46, that would be equal to 2. Now this can be also written as 46 ampere direction clockwise, and that would just simply do it I2 minus I3, because here I2 is going here and I2 would be going like this, I2 would be going like this and I3 would be going like this, which means I2 is dominating, since it's the current 2 amperes is flowing in that side, is equal to 48 minus 46, that would give us 2. So the question does not simply end here. We need to find current through 5 ohms resistance. What would that give us? Now current through 5 ohms resistance is actually I3 is in clockwise direction, so I3 is going like this and I1 is going like this. So I5 is equal to, since I3 has a greater value, that is 46, and I1 has a lesser value, and also they are in opposite sides, so it would be I3 minus I1, which would give you 46 minus 20, that would be 26 ampere in upward direction, and that is the current flowing through 5 ampere. And this was an example of super mesh. Thank you.